Hi, welcome to Rick Electrician YouTube channel. Today's video will be learning how a drawer is working. Okay, we will be simulating a drawer's functionality with PLC program. Okay, now I will give you a little introduction about the hardwares here. The first one is our power supply, then we have a small VFD, then one network switch, one CAN bus to the Modbus Converter, and our PLC controller with communication adapter RS422-485. Then we have our joystick. This is CAN bus joystick. It's not like other joystick. It's working with communication and induction motor. Giving a little idea of network connection, our joystick is connected to ODOT with CAN bus communication. Then this converter convert that CAN bus to Modbus TCP and coming to the switch, and the other side of the switch is going back to the PLC, so we get all the data to the controller, and from there again we writing back to VFD through RS485 Modbus. It's Modbus RTU. Then it's coming back to VFD controller. Okay, then VFD operating this three-phase induction motor. About the joystick, difference between this joystick and the regular joystick, that in regular joystick each signal is going with a single wire or multiple wire. Give you an idea, one digital output is one wire, one analog output it can be two wires, sometime one wire, but in actually we have here 7 digital outputs and 2 analog output, one for this switch and another one for this movement. This all going through this two wire. That's the difference between this type of joystick and our conventional joystick. So we have here different communications. We have CAN bus, we have Modbus TCP IP, we have Modbus RTU, then our Profinet. So four network we are using for this project, and we'll see how this is working inside the program. Okay. Okay, this is the program for this project. This program I cannot show you how writing, because it's a very big project. Actually it took me 1 year to understand all the hardware and its protocol and the data structure to make the project. It took me 2-3 days probably to make the project, but it was like 1 year of research I made to complete this. I will give a little guidance. I can give you a little introduction for the project. So we have joystick data. So what we're doing here first is calling the joystick commands. So what's happening there, we have a CAN bus joystick is 4 wires, so the data coming in 2 wire for all the axes and all the functions. That will be going to a Modbus CAN bus to Modbus TCP IP converter. Then you have to program inside. You have actually to parameterize inside converter. then you get Modbus output. So Modbus output coming to PLC, and we use Modbus TCP client to receive the data. Okay, so that program you can see here. Let me see where I can show you the program. Okay, this is the block using to collect the data from the joystick. So once you get the data from the joystick, it will be it's actually a bit by bit. The joystick has a data structure. Each functions working within the structure. So these are bits and bytes, and you need to organize them to a readable way for you to program. In our case, I made a joystick data conversion, that's here. So each bit I brought to the program and define the names. For example, here is front middle push button, front top push button, and front this is deadman switch, push back push button, then your remaining buttons, because you have many buttons, many axis controls. Once you finish all of them, then you have your analog detail for your axis movement, which is converted from bit to a word. So that will be coming like an analog. So they're actually a bit by bit. Then you need to convert them back to a readable format. This is what you can see here if I move the joystick. Okay, so that's how we bring the data. For example, if you want to see in real action when we operate, so when you push the button, it will come here like your regular program. Earlier we see the program of all type of joystick which has digital input directly. So in that case we connecting directly to the IO module input outputs. Here we getting from network, and we again putting back to tags. Once you have in this position where in the tag, then the function for programming remains same. Okay, after now we have all the inputs and output from the joystick. Then we need to operate the VFD from this command. So that's the program here. So let's see here. This is actually the program which I use. So I'm taking the joystick command, reference command, analog reference command, and sending to VFD to give the frequency for the motor. So it's a scaling. So let's see here, this is 2000. This number you can change based on your frequency requirement. For example, if you put here 2500, it will come 25 frequency. So that's how we sending command back to the VFD. Now we'll go how PLC communicating with VFD. Here I have a Delta VFD which is using Modbus RTU as a communication protocol. Now I'll show you. So this is the block where we communicate with VFD to send and receive the data. In our project we have programmed for few parameters from VFD. That's your frequency writing to PLC to the VFD, and the direction. This control direction, you have a program for the control direction here. Control direction of joystick. Let me see, I need to find that. Okay, drawers here maybe. Okay, no. Okay, here is the control direction. So I put in the joystick you have two axis detection sensor, one for forward, one for reverse. So I put forward for the forward direction and the reverse for the reverse direction. So when you are in the home there is no movement, when you go out from home you will have movement, and this is detecting the home position. Now the joystick in home position. Once you move out from home, you can see it's detecting the movements. Okay, so that's how the movement detection working. Let's come back to the VFD block. So control command is for to telling to VFD he needs to go in the forward direction or reverse direction, and frequency command is how much speed he needs to maintain. So everything controlling the motor is the responsibility of VFD, not actually responsibility of PLC. So PLC what giving command to VFD for speed reference and directional reference, or sometimes it can be torque also, but in my case I'm giving only two reference. One is speed and one is direction. So when there is a zero speed, in the VFD parameter we program that it needs to be a full stop, no movement. And there is also acceleration and deceleration parameters, torque control parameters, all we have in the VFD. This all the time remain in the VFD controller. The input what we need from PLC is speed command and directional command and sometime torque command, but for drawers we can keep the torque command as maximum, so we don't need every time writing torque command. Torque command remains same, just only the frequency and direction command. So okay, that's what for the VFD side. So once VFD getting the command, it start operating the motor. You can see here now I'm giving commands, and you can see that 34 for counterclockwise and 18 for forward direction. Actually this VFD has a different it's in the communication. If you go in the communication page of VFD parameter, you can see how the controls working from the network. So they have a data structure, then you need to read and understand the data structure, then according to the data structure you need to operate the motor. So these are based on drive to drive. The different drive has different parameter, and we are now looking our MS300 parameter. and according to that we write the program to VFD what he needs to do. So once the VFD has once you set up the VFD communication with the parameterization, then you need to write the function commands, what to do and what not to do. So this is basically here. Okay, here is all mixed. Yeah. Then I have wrote some command here. So I have one command. It's a, you can see sometimes the speed reduction, like when you need to go in a slow mode, you will be pushing some button, then the speed change. That functions are normally we are writing in the program to reduce the speed and so on. So in my case, I have two set of speed reference. You can see one is normal speed, which normal operation, then one is reduced speed. When I press this button, the speed will reduce to 20% of your actual record frequency. Then as soon as you release, it will be going up again to the full mode. In upcoming videos, I will be explaining you more about the VFDs, about the converters, joystick and induction motor. Keep watching the videos, so you will be getting more information about how a induction motor working and how these hardwares are working internally.